Continuing our discussion of ways to measure precipitation at a point, we now need to consider snow. The last two methods that we talked about, the tipping bucket and the weighing rain gauge, those can both also be modified to measure snow, namely by heating the funnel such that it melts any arriving snow and causes it to turn into a liquid so it can be measured. But that's problematic in a lot of remote settings where we'd like to measure precipitation because heat requires a significant power source, and many of those places rely on solar panels in the winter when there's not much snow, not much sun, and the solar panels could be covered in snow, and so it's not super effective. So one of the other ways that we measure the amount of precipitation in snowy areas is to put in these things called snow pillows. So here I'm drawing a vertical cross section. This is the ground surface here. And you dig a hole in the ground and you put in this kind of big bladder and you fill it with a liquid that doesn't freeze. And you put inside of here a pressure transducer that can measure changes in the pressure in this liquid. And the idea here is that as a snowpack accumulates, it increases the overlying weight on this pillow, and it squeezes the pillow and increases the amount of pressure that's felt inside the pillow or inside this liquid bladder. And you can calibrate this to measure the change in weight and therefore the amount of precipitation that's coming in on any given day. These are fairly laborious to install, and there's not that many of them. Another common way of measuring precipitation is actually fairly old-fashioned, and it consists of these things called snow-tell surveys. And these are surveys where people go out through mountainous areas, typically on skis or snowmobiles, and every month or so they make manual measurements at a whole bunch of different sites called snow-tell sites that they revisit over and over. And they're making measurements of the depth of the snowpack and of its density so that they can figure out the liquid water equivalent in the winter. These are some of the most reliable data, but unfortunately because they require so much human power, they're relatively sparse in terms of their spatial scale. There are a couple of other methods of measuring precipitation at points that I want to talk about, and we'll call these non-conventional methods because they're a little bit less common. One of these is to use an optical gauge. And the idea here is that you have a source of light and a receiver. So this is the source, and this is the receiver, and this is a light beam. And as droplets of water or snowflakes fall, they interfere with this beam, and based on the duration and the number of interferences, you can estimate both the amount of rainfall, but you can also importantly estimate something about the size, and in some instances that may be really useful. If you're really interested in the size of the particles that are falling and not just the volume of snow or rain that's falling, you can use this thing called an impact disdrometer. And the idea with the impact disdrometer is it's kind of like a drum. There's a taut surface here. And as raindrops fall on it, they cause vibrations, and what the disdrometer is doing is it's measuring the mechanical impact of these falling raindrops. And it's been calibrated in such a way that the signal that it picks up can be correlated to the size of the falling raindrop, which in some instances is a piece of information that's really useful.